Hey everyone, welcome back in the afternoon sessions. My name is Gunnar. I work for Salesforce as a software architect on our core developer experience team that's taking care of the monolith. And my responsibility in particular is build and IDEs. I'm talking in the next couple of minutes. Actually, it's good that we have a couch. It's like a therapy session. I can share my experience from migrating our monolith from Maven to Bazel. We're not done yet, but we're on our way. Let me start with giving you some context. So our code base is a monolith that really is a single web application which implements many products on top of it. And as of today, we have, I think it's about 120, 130 million lines of code. But one key thing, and this is important, is it's one development process that we use throughout the monolith. All of this code is in a single repository. I'm using single, not mono, because we do have dependencies that are only used and built for the monolith that live somewhere else. The reason becomes obvious when I talk more about our build, the legacy one. The other thing in that single repository is that over the years, there's additional tools, scripts, and other pieces just dumped into it, which makes our job a little bit harder because we have to now find out, well, is this important for the migration or not? Do we need to support this use case, etc.? We have, luckily, only 2 active branches that we need to deal with, main and a patch branch, which is like the current production branch and the next version of it. The dominant language in that monolith is Java. Now, when I say dominant, it is the backend is Java, but we also have a bunch of JavaScript, and this is why I'm not using the term monorepo. A lot of the JavaScript is currently being developed outside of the monolith because it's JavaScript, it's TypeScript, and it doesn't fit well with the Maven build workflow. One thing that's very consistent in the monolith, it's not the only thing, but there aren't many, is the growth. So over the years, we have 20% code growth year over year. That little flat line you see there is actually that was early 2020. There's a few hypotheses what has caused that, but the growth is consistent across all languages. So we have the XML is the top one, but XML is not really a programming language that we use, but we actually have a lot of source code generation happening out of these XML files into Java source code. So to that extent, XML and Java is sort of in the same bucket, but there's also some, well, JavaScript is growing, SQL, etc. There's 3,500 people, developers working in that monolith, or to some extent with the monolith. Some have their repositories out there and then just ship into the monolith. But the majority is actually needing to do code modifications in the monolith. And we have about 270 teams that we're working with or that we are supporting as the build team. Now to the interesting part, the legacy build. Initially, there was only Ant. And I joined Salesforce 2016. And back in the day, there was a project happening right now when I joined to actually bring Maven into the build. The way this happened is Obviously, the Ant build was producing a single jar and a bunch of other artifacts, but the main thing was it was doing the compilation of that jar and then also running source generators. So the very first activity of that Maven project back then is actually creating a structure, untangling all of this, and then they took that single jar and made it the very first Maven module. And then they came up with the concept of how do we extend this with other modules, module types, etc. But the key point is that we never really got rid of Ant. So Ant still today is sort of the core master of the build. Maven is used for source generation, for compilation, and in principle managing the class path using the POM XML files, dependency declaration, dependency management. That at the end of the Maven build, that class path gets dumped into a file, and then Ant takes on. Because it was Ant, we still have tools in Ant today that replicate the IV output back from the day. Of course, it's heavily optimized so that we do link in, file system links back into the Maven repository so that we don't need to download or move artifacts around. But still, it's two worlds. You can't just do Maven, you also have to do an Ant build in order to be launch and run the app. So it all started with that single module. Today we have 6,000 Maven modules. Now, not every single Maven module is actually a feature or functionality. We have this pattern that when you want to, or this convention that when you create a component in our system, you have to create a Maven module for the API, one for the implementation, for unit tests, and for functional tests, and so on and so on. This actually helps us with the migration a lot because we can rely on some assumptions in these modules. However, no single developer is compiling or building 6,000 modules locally. And Maven is not very great at picking what you want to build. So back in the day, when they started this project, they already predicted that we need to be able to build or work with only a subset of the reactor. For those not familiar with Maven, Maven calls the thing it builds a reactor. It throws everything in, and then it compiles everything and runs the plugins. And the team back in the day created an extension to Maven that we call partial build. Partial is really just allowing the developers to select a subset of the modules that they are working with. They're sort of their working set. And really the idea is build avoidance. Because we have the CI systems, they compile all these modules, they produce jar files. We know exactly the revision. They stick it into a Maven repository. And then so all that partial build extension is doing is when a developer is building, it's downloading those pre-built artifacts for that particular revision, and then only compiling the subset or generating the subset locally. So it's not incremental. It really is partial because it's always a static subset. And it's also not really content addressable because really you pick the revision and then you go to the next version. So there's a bunch of work also went into to make sure that we only submit delta so that they don't have to download every jar again as soon as they update. So that was one critical piece. The other critical piece then is because, yeah, there was still the original module, which is like a giant Maven module, and just compiling that module itself is 10 minutes. So they decided to, we need to make the Java compilation within the module itself, as well as the source generation, incremental. And who here has heard of the Takari extension for Maven? Not a lot. See, it's an extension to Maven to actually support incremental compilation in Maven. It's very, the only reason it exists is because back in the day, Salesforce hired a bunch of Maven people and they did that, right? So it's optimized. But that wasn't enough. 2 years ago, we actually reached a critical point in our system, and the build was slowing down tremendously, and we realized that it's the JVM executing Maven build, doing a lot of garbage collection. And the reason is the memory model of Maven is just not built for that scale. So we already had an internal fork, but it was very, very small. But we know exactly through enforcement which Maven plugins we're using. So we were able to tweak the memory model of Maven to avoid, so Maven has everything in a POM XML file, and that's XML, by definition very verbose. And of course, everything is held in memory. And then when Maven invokes a plugin, well, it's single process, so the plugin could potentially change the build model. So what do? It's not immutable, so they just clone it in memory. And then for every single plugin invocation, the whole build graph, the whole dependency graph, the Maven model gets cloned and cloned and cloned. There's a lot of garbage collection happening. So we were able to, because we know which plugins we're working with, we are very strict around governance at that scale. So we were able to tweak Maven to make it work for another, hopefully next year is the last year. That's a view of our dependency graph in Maven. That thing in the middle, that's the original Maven module. So we did all this work and we brought structure in the build, but then we never actually finished cleaning up the original module. So if you take it, no matter how you take it, it's an hourglass, right? So, and what does it mean for Bazel, for incremental build? It's a lot of work, right? Because like there is, depending on what side you look at, but actually the left side is the smaller one is the bottom of the graph. So if you're making a code change there, there's a pretty good chance you end up building 80% of the whole app. You end up doing a full build, almost a full build. Okay, there's some exception. And this is where we actually went and looked into what code changes are our developers doing? What's going to submit it into the repository? So we went through the history of the code base, and then we started categorizing those changes. And based on those categories, we were able to, because we already had a POC running, so we were able to predict or guess the improvement or the penalty that Bazel would give us. Turns out it's not too bad. 75% of the code changes that are submitted would immediately benefit from Bazel. There's some nuances to this because like you typically, the code change that's submitted is the result of a series of iterations, but we didn't bother looking into those because for that reason, as our developers use an IDE, and IDEs, they are very fast. They just, you modify a Java file, you save it, and then it's instant. There's not a lot of heavy build activity. So we ignored that piece of improvement and just looked at the general ones. Because we wanted to see how can we approach this migration. So we came up with this idea of, can we migrate in a way that allows us to pick changes and make developers doing this based on what they are doing, based on the job they are doing, using either Bazel or Maven. But first we had to also look at a few other requirements that at the scale of how we operate and what we do, we had to be very careful to make sure that we're not doing crazy things. So 3 key points here: developer experience, productivity, and risk. It was 2019. I was sitting there, well, not here, but at the BazelCon in 2019, watching a keynote from BMW where they basically just migrated all of their code in a week or 2 weeks by having all the engineers working on it, moving everything over, and then spending another 2 weeks, like 4 weeks, done. So I was talking to my leadership and like looking, can we do like stop? Right, that was the majority of our teams are feature-based. So a pretty important requirement for us was no disruption. Whatever we do, like we cannot disrupt what they are doing. The show must go on. Also, big bang is a no-go because of this, right? We need to make sure that whatever we do it in a way that allows us to move forward, and if something breaks, take a step back, redo, but don't break production. Ensure that the path to production is always stable. And the developer experience itself was basic things, right? IDE support, it needs to continue to work. Dependency management. Maven is very great for developers because you can transit this for free. Oh, I just want to use that single library. Oh, great, put it in, right? And then all of a sudden it comes with this 500 friends, it brings everything to the party. So we actually did try to trim down the Maven transitive dependencies at some point, and that was a failed experiment because then we ran into a lot of issues with our application. Yep, that is another thing that we need to be, that also you need to consider when you're doing this Maven migration. And of course, the learning curve is like, how do we train, or how do we make sure that 3,500 people are able to learn and adopt a new build system? Well, sometimes you don't, because it turns out that out of those many developers, not every single one cares about the build, right? Some really want to just they work on their feature, so they happily take whatever the documentation says and do it. So the learning curve can sometimes be mitigated by just providing the right, adopting all the documentation, which is a different problem of chasing down 270 teams, each team having their own documentation of how to do things internally. But we started with that migration. Let's build a parallel submission pipeline. Remember, we had that one process everyone has to go through. So you're doing your change, you're doing it locally, you're testing it, but at the end of the day, you're submitting it into a system that we call pre-check-in or pre-submit or other works. And then that system, that pipeline, does a lot of testing, building testing, analysis checks, etc. And at the end of the day, when it's good to go, it merges it into the repository. So our plan started with, okay, then let's analyze the change and then make a decision whether the change is actually supported by the Bazel pipeline. And then we build it with Bazel and merge it in. And then otherwise we run it through Maven. And the idea was that our submission pipeline is, because you always have to think about the developer benefit. What's the benefit of this approach? Our submission pipeline is running a full Maven build, and then all the tests, right? So our idea was with Bazel, we can actually use, and we do have warm build nodes, so we can use a local cache, and then run the submit through this one, and then benefit from a much faster build. And as I said, right, 75% of those changes, that's what our analysis showed, would immediately benefit from this. So you're making a label change or something, right? Or you don't have to go through a full Maven build. You just submit in. That's what Bazel is great for. So we started a journey. We had to write about 40 source generators. We had to wrap into Bazel rules. Luckily, a lot of those source generators were written before Maven got introduced. So they already had a Java main method, and it was easily to invoke them as a process from a Bazel rule, right? There's only a few which were only available as Maven plugins, and those we actually had to work with their owners to make sure that we can call them from Bazel, and also a few we optimized because the old ones they were very they didn't pay attention in the old days to the inputs and outputs. So most of them just took a directory as input and then searched for the files in the implementation themselves that they needed. That's not good. So those are little nuances that we had to do. We were hoping to get rid of a lot of source generators. Unfortunately, this is where the Maven dependency problem comes into the picture. Some of the source generators, especially around gRPC, is very complicated. So we had to actually wrap our internal ones in order to produce the same output that the Maven build is producing. The migration tool did analyze the Maven graph. It read all the POM.XML files, and then out of that translated that into a Bazel graph. So we know we used the plugins, and for that plugins we generated the source generator target, and then at the end of the day we generated a primary target that was sort of matching the Maven main artifact. It worked pretty well. We were able to run the migration tool on the Maven code base and then just do a Bazel build, and it would build the entire app. And then you could do Bazel run to start the app. We had to do a little bit more things to make it work or to make it efficient. For example, we had to rewrite our application launcher because, as I said, initially a lot of launching logic was still in Ant. So we had to pull it out and make sure that we have a pure Java-based or pure process-based solution that we can use with Bazel run. That, of course, caused a little bit of complications because Bazel run is running it from not from the working directory as in the sandbox, but we got that sorted out. A few remaining problems is we weren't able to get persistent workers done because we ran into memory issues. Some of the source generators are not great at being persistent. Turns out that we looked into the Maven implementation, and the Maven implementation actually was forking a process for them. We wrote a proxy to be able to avoid basically re-downloading all the Maven jars. And also back in the day, when we started this 2.5 years ago, there was no, the support for authentication wasn't great. And we had to build our own Java toolchain because, guess what? 6 years ago, they realized, oh, wait a minute, we're working in the IDE and we're getting a total set different error messages than the command line builder is giving us. So they made an effort to make sure that both Maven and IntelliJ are also using the Eclipse compiler so that we get consistent error reporting across all our tools. And it turns out we couldn't even just flip back to the Java Z1 because there's nuances in how the compilers interpret or read the Java language spec around generics. So some constructions that work pretty nicely in Eclipse and make a lot of sense are impossible to compile with Java C for whatever reason. Oh, and we had this experience of, we'll almost been 98% done because we had a green build of the pipeline, and then every other day, some developers was checking in something that we had to update our migration tool to support it. So we started to have some doubts on this approach. And those doubts actually got stronger once we started analyzing this type of changes. We went, hold on, who's actually submitting them? It turns out 70% of our developers are during a release cycle or during a phase are doing one of those bad or expensive changes once. So we had to go back to the drawing board. And also that with the migration tool, we still had the open question, well, how do we make the flip, right? Because even though we're pretty confident that the pipeline works, as we cannot just say for the developers, hey, today's code line, we're cutting the release branch. Monday, when you all come in, we use build files. It's not going to work. So we had to do something. And here's a key idea that a team member had that was previously working on the Maven build and partial build stuff. So he's like, we can just hack Maven again and make Maven read job files from the Bazel output folder. So we could start doing a Bazel build first, and then with that output, we do the Maven build, so that we can start handpicking modules and moving them into Bazel, like from the graph bottom up. That was very important because this really allowed us to go with the incremental approach that our management also always wanted to have, right? So we plugged into the Maven resolution and made it possible for you to declare a dependency on // whatever, and that whatever gets translated into an artifact ID that gets translated into, the other way around. In Maven, you make a dependency on artifact ID is the name of the Bazel module on the file system, the Bazel package. And then we resolve it from the Bazel output directory. And over time, we would just increase the Bazel build till eventually there's nothing left to be built in Maven. Second thing we did is with these generated build files by the migration tool, we realized, oh, hold on, that sucks from a readability perspective, because there's like a build file and it has these gazillions targets, and who's going to govern that? So we came up with the idea of defining a single macro that our developers use. And so this is what the POM-XML became to for a module. We wrapped everything into a macro. It has a name, it specifies the dependencies, runtime dependencies, and the source generators. And once we did that, we then did the next step and reminded us about ourselves of Maven Polyglot. This is a nice feature, because this allows you to tell Maven to ignore the POM-XML files, use starlog. So we were able to decouple the migration from the translation of the POM-XML files. And that is something that we were able to crowdsource with the teams. It's like we asked the teams, hey, every 270 of them, go translate your POM-XML files to a build Bazel file following that new convention. And well, we actually had a generator that would generate a preview file. So the only thing they had to do is copy the file, delete the POM-XML file, and then go through a list of to-dos to clean up, because we also wanted to do some cleanup. The most important one being eliminating transitive dependencies, right? Because like we could then read the starlog file, the build file, and generate the Maven in-memory model out of this, and apply exclusions in Maven so that the Maven compile class path would be exactly the same as in Bazel. The other thing we did, and also with the help of Maven Polyglot, is that we moved all of the dependency definitions that we had out of the dependency management sections of the POM-XML file. We had a single parent file, which has, and we used dependency management heavily in Maven, to move that out also into a new Bazel starlog definition, and then use Maven Ether to pin that down. So similar to rules external, what Maven install is doing, right? Except that we're avoiding a contention on the single file, so we spread it out into many, many files. Basically, a file per group ID that looks something like this. So we have a file called com Google Bazel, and that's the dependency collection. You define a list of Maven dependencies. You can use variables to pinpoint the version. You can go larger with classifier and packaging type if you want to, but you can also be very short. And then we pin the catalog, which is then read by the workspace file. Okay, well, see, there's one missing. So as of today, we are totally done with the translation, and we have 14 modules already built in Bazel. It doesn't sound much, but it's actually very, for us, it's a very big story, because Now we know Bazel is already in use end-to-end in our production pipeline. There's a lot more that we have to do, especially around IDEs, remote caching and packaging and such, but yeah. So if you're looking into this, keep in mind that you can also change Maven and not just to go to Bazel. Thank you.